Hi, thank you for having me here. It's great to be back at the INC. I've really missed not being here the last couple of years. Want to say thank you to the organizing committee. I know this put 3 years of work into making this conference happen. Also, thanks to the INC council for always making these INC meetings possible. You know, I've been working on AllSky7 for a few years. I have talked about it before, and I just want to give kind of a historical background of the motivation, where I've come from, what's in my mind, and where we are now and where we plan to go. Really, my meteor career started with this photograph. Some of you might know about the story, but it was an accidental photo through my telescope of a Molau that launched a meteorite hunt for me in the Pennsylvania area. That's kind of like my baptism of fire into the world of meteors. The concept of the AllSky7 came to me about 5 days after that event. I hadn't slept all 5 of those days because I was so excited about Fireball. But I never found that meteorite that I looked for. But over that time, I learned a lot about meteorites and meteors and fireballs and bolides and how to really triangulate these objects. And, I had no real data beyond my picture and maybe 2 bad videos of that event. So I interviewed a lot of witnesses. And through that, I got the idea to, develop an enhanced version of the AMS Fireball reporting tool. All of you are probably familiar with. And, this has evolved over the years, but, the main point of it was to narrow down the area where the fireball happened. It wasn't trying to get perfect track or anything like that. We just wanted to narrow down the area because in the US, we have a radar system that if you know the time and place of the fall, you can look in the radar and you can find a signature of the meteorites. You go underneath of that radar and boom, you're in the strewn field. This, process was significantly enhanced and improved because of the AMS witness reports, because we could get the data out so fast. And in 2012 alone, we had 4 falls that used this system. And by the end of 2012, I really thought the meteor world couldn't get any better. But then 2013 came along, and it got a lot better. But this event that we all hopefully are familiar with is what led me to the IMO and my first IMC in Poznan. And I presented with Vincent, who's the main developer of the system, our idea about the witness reports and that system. And in this same talk, I alluded and briefly touched on our AllSky concept, which back then was just AllSky1, Raspberry Pi, LaTeX fisheye system. But the main thing that came out of that IMC was that we made an agreement with IMO to license this software across the world. And with the partners of the IMO, we translated it into over 30 languages, something like a dozen or 20 or more associations. And the just amount of reports and events and documents and meteorite falls just went through the roof. Now this kept me busy for a few years, and I had a little hiatus between 2013, 14, 15. I didn't really even know where I was going to go with my meteor career after that. And then one Sunday morning, this fireball ripped through Florida and left a giant radar return. Friend Mark called me and said, "Hey, there's meteorite fall real close to you." And I said, "You know what? It's cold. It was in February. I'm going to drive down to Florida and look for this meteorite." I did. And the very next day, I found the first meteorite from the fall. That little guy over there, it's like 7 grams or something like that. And then later that day, my friend later found one. The next day, his aunt found one. And then the next day after that, I found one again. Then I went home. They continued. They found a few more stones. My friend Brandon, old college roommate, was really happy to get that big one. This got me serious about meteors again. And the first thing I did was I automated a system to search the radar so that I wouldn't have to rely on Mark or a manual process to find these radar returns anymore. But that wasn't enough, because even though we had this great way to find meteorites, we had really no way to find meteorite orbits. And there's only at that time about 30 of those in existence. A meteorite that was found with a photographic record with an orbit. And you can now work to 41 of these. You can find all of them on a website called meteoriteorbits.info. It's not my website. I don't know whose it is. It's a very nice site though. But at the end of the day, we want to make this list longer. And that's one of the main objectives of the AllSky7 system. Already, we've contributed to some of these, even going back to Sutter's Mill, which was my first contribution to an orbit. The Osceola is there, Flensburg was another orbit. But this is really, in my mind, the holy grail of fireballs is making it onto this list. So that was really the first motivation of the AllSky7. Find meteorite and get to orbit. The second motivation really comes from running the witness reporting program and just, the human, nature of like wanting to find patterns and things. Sometimes the patterns aren't there, sometimes they are, but there's just been enough, let's just say, strange recurrence of fireballs in my mind at certain times, often near IMCs, that make me want to learn more. And where this always left me was, you need camera data. It's an interesting idea, but you need camera data. So what do I really want to wonder about is, are meteorite producing fireballs more active on some days of the year than others? Is there one day of the year that is the asteroid day where fireballs are just enhanced? What's the busiest month of the year for fireballs? And I'm not talking about shower fireballs. I'm specifically talking about asteroid fireballs. And really, could there be some process that's taking place that's sending fireballs here on certain times of the year? And could we figure that out? A stream, so to speak, much like a meteor shower stream, but less dense and less events. While I was writing that slide, this memory popped up on Facebook for me 8 years ago that said, American Meteor Society reports 4 fireballs in one night. Well, at that time, I thought it was a strange occurrence. So I put that up, I made that blog post, and the media loved it because it was sensational. But, later I come back to this idea several times. In 2019, I put together this spreadsheet of like falls by day of AMS and CNOS, and then the number of years that those falls would recur to just get, and then I multiplied those numbers, together to get this kind of score. And when you sort this list, the highest ranked date is February 15th, which is the day that Jellyman's fell. Now, maybe that's just a strange coincidence. I promise you it's not a parlor trick. I'll show you the data, share the data with you. But then, the next dates is like 9/24, 9/7, 9/5. So there's certainly something going on in September. Maybe it's the Taurids, but I actually extracted out a lot of Taurid data, in this version. So again, not conclusive, but kind of going in that same direction. So what are the kind of processes that might make this possible? Hubble telescope has actually imaged several asteroids that are deteriorating. This one was listed as a mystery reason. Here's one that is emitting dust so much from a rotation that it's creating these tails. Now this one is my favorite because it came out in 2010, right when I was getting into this, and it's a head-on collision, they think, of 2 asteroids taken by the Hubble. And each dot there, I don't know how big that might be, but it's potentially going to create a fireball. So, if Earth was going to pass through a field like this, could that create a recurring stream of fireballs? That's like kind of why I created the AllSky7, or why I wanted to create the AllSky7, was to get these orbits on the fireballs and have more than just a date and time, enough to kind of either prove this theory or prove that it's wrong. This is where the AllSky7 is. Sirko has done a lot of work on this. It looks great, but it didn't always look like this. It actually started pretty primitively. This was one of the earlier versions. I was very proud of it at the time, but when I look at it now, I'm kind of embarrassed, but you got to start somewhere. I presented this idea, in the 2017 IMC at Nizza, and, there's the 2 dogs, Blackie and Brownie. And, this was still just very much in the beginning phases. Within 1 year from that, in 2018 IMC, I kind of finally had what I felt was like a near close to finished product. And I presented this. This was really pivotal IMC for me because of a few reasons, but one, there was a speech from Pavel Spurny that was, a little critical of meteor orbits and just this type of work and bad data, really, or bad conclusions. And so that kind of set me in my mind at a critical time. But he made a comment in that speech where he said, meteors are business. And I said, you know what? I need to hear that. Meteors are business. That's exactly what I need to hear to keep pushing forward with this. And the third thing that really happened at this was that the AllSky7 very much attracted the attention of Sirko, and he purchased the first demo unit that I had brought there with him. Now, that next year, we really rebuilt the entire system. We swapped out cameras and many things. And then we returned back in Germany. That's Sirko's house with his AllSky7 on the top. And he gave the now very famous speech of Frippon versus AllSky6. And gave it the spicy tag there. But, it was still not entirely a completed project. After IMC, I left, the German IMC, went to Flensburg, where we had just captured our first daytime meteorite on the AllSky7, and Jerzy Borowiczka made the orbit with some other cameras and the help of Felix, and it was really an exciting meteorite, exciting project to be part of. And I got to meet the finder, and he showed me the exact place where the meteorite was in his yard. We hunted around there. I actually went to an abandoned military base, airport that we hunted. It was probably the neatest place I've ever hunted meteorites before. In 2020, 2021, I leave this slide blank for, all many reasons, but during those dark years, there were some good things that came out of it. And one was that, what I consider to be the, European explosion of AllSky7, mostly helped, by Sirko up here. He went through, we converted from a 6 camera to a 7 because there was a little bit of a gap in the field. We painted the dome, and then, we've gone now to an 8 camera system, added, I don't even know how many, maybe over 100 stations. So it's like 700 cameras. And while he was conquering Europe, I was slowly, sporadically filling in the gaps in the US. But we've also added some Asian partners who covered the peninsula of Korea. We have a guy in India who's kind of trying to get things going. And we also have a project in Mongolia that's going to hopefully cover those dark skies there. Now, ultimately, what are we doing? We're trying to get meteor observations, group them together, and have them solved. We're using the Western Meteor Python library to do that, which is an amazing program. And it really, one of the things it does is it gives you these graphs that can tell you how good or bad your solutions are. Sometimes they're better than others, but almost every event has some problems. And with more and more observations, it gets more and more complicated. So, on a running day, we might be looking at 50-50 on our events that fail or pass. And what I mean by, pass or fail is just like, if it has a -a variable, semi-major axis, or an E variable greater than 1, I consider it to be a failure, and there's something wrong. So, that's one of the problems. That's probably my biggest challenge right now, but there's other problems and challenges, manufacturing, consistency, just completion, finishing off the product, establishing a business model or funding source is also very important, because as we get bigger, it costs more to operate. And, just dealing with big data is a hard project, especially when you have video data. It takes up a lot of megabytes, gigabytes, terabytes. And, that mainly the initial design relied on the operator to do some things, delete bad meteors, calibrate the system, or at least notice if it's not calibrated, and maybe refix the points. And it's hard because not everyone does it. So the other thing that's hard is this UI that allows this is posted on the station. And so if that guy has a bad internet connection or no internet connection, it makes accessing the data and fixing up the data hard. But ultimately, what we're trying to do for each meteor is have a few stars, hopefully, that can prove what our astrometric field looks like, and then a point for every frame that goes to the meteor. Bolides, fireballs, it's harder to get this right programmatically. There's so much fragmentation and whatnot. Okay, so really, I don't want to go through every detail here, but events fail because the input data is bad. That's the only reason. There's several reasons why the input data is bad. And there's some things that you can do. You can have human intervention. You can have better software. That's ultimately the best solution. But we can also have now AI and machine learning solutions and bots. So really what I'm trying to do is not replace the human operator, because we need the human operator, but give him a bot that can help do the work for him. So if he's not there, doesn't want to do it, it still gets done. The AI is, kind of a newer project, but I'm really happy with where it's at now, but it's still evolving. We're not just focused on yes, no meteor, but all objects that flow through the system. We record 24 hours a day, and then we detect. So there's a lot of other uses for the system: weather, monitoring planes, bird watching, and all these types of things. So we have a labeling system that for moving objects that are not meteors, now operators can tag what they are, and then we can use that data to later build new models, to improve the models, and so on. Okay, I'm running out of time, so I'm going to go faster. But in the the calibration, this is one of the problems that can lead to errors or failures of events. And so again, I'm trying to do this in an automated way so that the user doesn't have to do anything. And everyone here is really smart. You guys know meteors really well, but not all operators are like that. Sometimes they don't even know what is much at all. Like they don't know what astrometry is. They don't know how to do the calibration, and they get really intimidated by these types of screens. So I want to be able to have this system work automatically. But what we're trying to do is identify a star in the field, a star in the catalog, and measure the distance between the two. And the least amount of distance there is, the better. And ultimately, it's important to get that below 1 pixel, below a half a pixel, whatever's, well, at least you can get it is the better. The way that my system works is that we track all of these, we take a calibration photo every 2 hours, and we track it for the life of the system. So if you move the system, you re-rotated it or whatever, we could historically go back and fix older meteors. We look at, every single one, and then we pick a few, try to spread them across the whole field of view, and then we run these through the lens modeling program developed by Dennis Vita as part of RMS software. And ultimately, what we're trying to do is get a nice azimuth grid where we can convert any pixel in the image to an azimuth and elevation. And the reason that we want to do that is because ultimately we want to find meteorites, and we want to be able to produce the meteorite orbits. So you might get something like this, a track. We would then get wind data, and we would run the wind data through another program developed by the Desert Fireball Network, which handles the dark flight, and then it would spit out coordinates, estimates for various size meteorite ranges. In this example, what I've done is I have the real wind data is the top part, and then the bad wind data, or really what I did is I reversed 180 the direction of the wind, and that's on the lower end of this. So it was more of just a test to see how much of a difference would make if the wind direction was completely wrong or the complete opposite. And it's about 10 kilometers. So if you don't have this wind data locked down, you're probably not going to be able to find the meteorite if you don't have the radar data as well. It's a really critical point. But if the trajectory is wrong, your wind data is going to be wrong too. So these are all part of this puzzle that makes it hard to find meteorites. So, said at the beginning of me being involved with this, compare meteorite hunting with Indiana Jones. So I'm just going to go with it. Dr. Jones, why do people hunt meteorites? Fortune and glory. Okay. But some people do it for science. Some people do it for fun, just because they fell. But really, we can't deny the fact that freshly fallen meteorites are the rarest material on Earth. They possess great monetary and scientific value. Only 1,200 or so witness falls have been recovered in the history of mankind. So if you find one, that's a big deal. Here is the last 20 years or so of how many witness falls per year occur. And for me, a guy trying to make the strewn field, I really consider the strewn field data a precious thing. Okay. A lot goes into it, raw materials, camera observations, And it's a lot of hard work to obtain this stream field data. And of course, once you have it, everyone is after you. And you know, you gotta be careful of the academic community. Maybe you're right. But you know, eventually you're gonna run into this guy who tells you that, you know, we see there is nothing you can possess which I cannot take away. And you know, this really drives me crazy and makes my life difficult, gives me stress. But I still want to figure out a way that we can work with everyone. We work with dealers and hunters, locals to recover, camera operators to recover meteorites as a team in a fair way to everyone. Now imagine negotiating meteorite hunters might start out like this, but it would quickly evolve into something like this, and it might even be more like this. Now, like Dr. Jones, I do not like snakes, and I really don't want any snakes in my meteorite working group. So, you know, how is this all going to work? Well, we had several meetings. Sirko has done a great job of, you know, organizing and you know, getting a community together and documenting these things. But, you know, we can't, deny the fact that the material is very important. And, you know, if we're going to do all of this work, go to all of this expense and, you know, build out this network, we want some of that material. I'm not embarrassed to say it. This is why I'm working on this so hard. But we also need you to keep confidentiality, because as soon as you tell everybody else where that stream field is, all the meteorites will be gone. We also want two-way information sharing, and we, you know, plan to do a consortium approach to all the paperwork, publishing. And you know, we want honest people. We want to use an honor system. No lying, cheating, stealing. Don't be a jerk. Those are the rules, pretty much. Okay, so as I was completing my paper, you know, trying to get out, or this presentation, trying to get out of the country to come here, we had on Sunday morning, we had this fireball in Korea, which was really interesting. The automated system has the res at 0.77. That's pretty good. I'm happy with that. And it looked like this. It started right on the border between North Korea and South Korea. It went through North Korea and into the ocean. So I was like, phew, it's in the ocean. I don't have to work very hard. And 12 hours later, we had this meteorite in Ireland, and it landed actually over land. There's only been one meteorite found in Ireland in the last 150 years. It was caught on 3 cameras. And then so I was like, wow, this is actually a pretty good one. And then the morning that I'm getting ready to leave, or that evening, we had another one in America, in Georgia. And at 5 in the morning of the day I'm leaving the flight, I got a text from a camera operator at 5 in the morning who said something, and then I didn't respond. And then he sent this picture of this meteorite and said, I found the meteorite. And then I called him, and you know, he had seen the meteorite on the AMS, the reports, went to an AllSky camera, got the time, went to the radar, got the radar, got in his car, drove for 4 hours, found the meteorite at 5 in the morning in the dark, in the middle of the road. Okay, so that's my talk. Thank you very much. You know, where we're going from here now, what I'd like to do is to really kind of slow down and take a step back and focus on quality assurance, making sure everything's working right, getting the solutions that we want, systems are automatically calibrating the way that we want to, and that we have a replicatable model that's going to work globally. And we're really close, but you know, it probably will forever be a work in progress. But thank you very much.